In this video, we're going to go through suggested exercises from section 2.1, which is operations with matrices. Let's go ahead and get started. Our first problem here is number 3, and it says 16, 4, 5, 4, negative 3, 13, 15, 6, 0, 2, 4, 0 is equal to 16, 4, 2x plus 1, 4, negative 3, 13, 15, 3x, 0, 2, 3y minus 5, 0. So in order for two matrices to be equal to each other, every single element, an element being a number that's in a row column position here. So this is first row, first column, element E1 comma 1 has to equal the same element in this matrix. So 16 is equal to 16, 4 is equal to 4. Here's the first equation that we can set up. 2x plus 1 needs to be equal to 5. Let's keep going here. 15 equals 15, so 6 equals 3x. That's going to tell us that x has to be equal to 2. So 4 plus 1 equals 5. 5 equals 5. Check, x is equal to 2. And then we come down here, 3y minus 5 is equal to 4. And then 3y is equal to 9. Y has to be equal to 3. So we have a solution of x equals 2, y equals 3 that will make these matrices equal to one another. Let's go ahead now and look at number 5. And number 5 asks us to do several different matrix operations. So we're going to have parts A through E for a few problems here. So part A asks us to add the two matrices. Part B asks us to subtract the two matrices. Part C says to find 2 times the first matrix. Part D says 2 times the first matrix minus the second matrix. And E says the second matrix plus half of the first matrix. So let's go ahead and look at number 5 says here. A is equal to 1, 2, 2, 1. And then B is equal to negative 3, negative 2, 4, 2. So I might as well, while I'm here, find 2A, which is 2, 4, 4, 2. I might as well find 1/2 A that I'm going to need later, which is 1/2, 1, 1, and 1/2. Just multiplying every element in the matrix by that constant multiplier. I am also going to need negative B here, since I'm subtracting by B. It's going to be 3, 2, negative 4, negative 2. And I'm going to need, that's going to be it. So A plus B is going to be 1, 2, 2, 1, plus B is negative 3, negative 2, 4, 2. So I'm going to add corresponding elements. 1 plus negative 3 is negative 2. 2 plus negative 2 is 0. 2 plus 4 is 6. And 1 plus 2 is 3. B says to add A and negative B. A plus negative B is the same as A minus B. So that's 1, 2, 2, 1. Plus, I've already found negative B, 3, 2, negative 4, negative 2. So that is 4, 4, negative 2, negative 1. 2A, we already found, was 2, 4, 4, 2. And then D asks us to find 2A minus B. Two, 4, 4, 2. So plus a negative B is 5, 6, 0, 0. Then E asks me to find B plus 1/2 A, which is negative 3, negative 2, 4, 2, plus 1/2, 1, 1, and 1/2. So this is negative 3 plus 1/2 minus 1, 5, 2 plus 1/2. So this is negative 2 and 1/2 minus 1, 5, 2 and 1/2. Let's make those improper fractions. Negative 5 halves, negative 1, 5, and 5 halves. And that's it for number 5. Let's go ahead and look at number 7. We'll be taking the same 5 steps there. Seven says A is equal to 2, 1, 1, negative 1, negative 1, 4. And B is equal to 2, negative 3, 4, negative 3, 1, negative 2. So let's add them together. 4, negative 2, 5, negative 4, 0, 2. Let's take A minus B. That's going to be 2 minus 2, 1 plus 3, 1 minus 4, negative 1 plus 3, negative 1 minus 1, 4 plus 2 is 0, 4, negative 3, 2, negative 2, 6. Part C asks me to find 2A. That's 2 times 2 is 4. 2 times 1 is 2. 2 times 1 is 2. 2 times negative 1 is negative 2. 2 times negative 1 is negative 2. 2 times 4 is 8. 2A minus B. It's going to be 4 minus 2, 2 plus 3, 2 minus 4, negative 2 plus 3, negative 2 minus 1, 8 plus 2. So that is 2, 5, -2, 1, -3, 10. 2, 5, -2, 1, -3, 10. And E asked me to find B plus 1/2 A. So that is 2, -3, 4, -3, 1, -2, plus 1/2 of A is 1, 1/2, 1/2, -1/2, -1/2, 2. So this is 2 plus 1, -3 plus 1/2, 4 plus 1/2, -3 minus 1/2, 1 minus 1/2, and -2 plus 2. So that's going to give me 3, -6/2 plus 1/2 is -5/2. 8/2 plus 1/2 is 9/2. -6/2 minus 1/2 is -7/2. 2/2 minus 1/2 is 1/2. And then 2 minus 2 is 0. So that's it for number 7. Let's move on now to number 13. 13 asks us to solve for x, y, and z in the equation for times the matrix x, y, z1 equals 2 times y, z, negative x, 1 plus 2 times 4x, 5, negative x. So let's simplify both sides. This is 4x, 4y, 4z, 4. This is 2y, 2z, negative 2x, and 2. And this is 8, 2x, 10, and negative 2x. So that tells me that 4x is equal to 2y plus 8. Tells me that 4y is equal to 2z plus 2x. Tells me that 4z is equal to negative 2x plus 10. And that tells me that 4 is equal to 2 minus 2x. This is the only equation with one variable in it, so I'm going to start there. 4 equals 2 minus 2x. So 2 equals negative 2x. X is equal to negative 1. So I've solved that equation. Let's use that x equals negative 1 to solve for y and z in equations 1 and 3. So negative 4 is equal to 2y plus 8. Means negative 12 is equal to 2y. Y is equal to a negative 6. Let's check my equations. 4x plus 2y equals 8. X was equal to, x should have been equal to 3. What did I write down wrong? So 4x, oh, this is a negative 1. Negative 1 down here. Let's check my problem to be sure. Yes, I apologize. So that is a -4, and that is a -4. And so that gives me a -6, and that gives me a +3. If x is 3, then 4 times 3 is 12. And then 12 minus 8 is 4. Y is equal to 2. Yes. And then done with that equation. And then if y is 2, I can come in here. Or if x is 3, I can come in here. Either way to solve for z. Let's continue to use x. So 4z is equal to -2 times 3. That's -6 plus 10 will be 4. 4z is equal to 4. Z equals 1. While we're at it, let's go ahead and plug in y over here, make sure that we get the same thing for z. So 8 equals 2z plus 2x is 6. 2 is equal to 2z, and z is equal to 1. So that checks out. My answer here is x is 3, y is 2, and z is 1. Move along to some matrix multiplication. It's going to be number 15. Matrix A is going to be 1, 2, 4, 3. Matrix B is going to be 2, -1, -1, 8. A times B means we're going to take our rows from A and our columns from B to make our new matrix. So let's go ahead and show you. This one is a 2 by 2. This one is also a 2 by 2 in order to be able to multiply them. The number of columns in this matrix needs to be able to equal the number of rows in this matrix. And I'm going to end up with this. So if we call this n by m and this m by p, n by m, and this is m by p, m needs to match, and we'll end up with a matrix that's n by p. So in this case, everything's a 2, so we're going to end up with another 2 by 2. I'm going to give myself some space. So I'm going to first row, first column here, multiply. So 1 times 2 is 2 plus 2 times -1 is -2. First row, second column to make row 1, column 2. So 1 times -1 is -1. 2 times 8 is 16. Now we want second row, first column. So second row, first column, 8 minus 3. Second row, second column to get second row, second column. That's -4 plus 24. One, 2, 4. This should be a 2. So this should be 2 minus 2, 1 plus 16. This should be -2, and this should be -4 plus 16. Okay. So this is 0, 15, 4, and 12. 0, 15, sorry, 6 and 12. Let's do B minus A, or B times A. So that means that I do rows in B and columns in A. 2 times 1 is 2. -1 times 4, so that's 2 minus 4. 2 times 2 is 4. -1 times 2. -1 times 1, -1. 8 times 4, 32. And then -1 times 2 is -2. 8 times 2 is 16. So that's -2, 2, 31, and 14. Let's do this again with number 17. We'll have some different matrices here. 17 is A is 2, -1, 3, 5, 1, -2, 2, 2, 3, which is 3 rows by 3 columns. It's what we call a square matrix where the dimensions are equal there. And then B is 0, 1, 2, -4, 1, 3, -4, -1, -2. So both of those are 3 by 3s. So my products should be 3 by 3s, and I should be able to multiply both ways. So 2 times 0 is 0. -1 times -4 is 4. 3 times -4 is -12. 2 times 1 is 2. -1 times 1, -1. 3 times -1, -3. 2 times 2 is 4. -1 times 13 is -13. Sorry, that's a 3. 1 is out of alignment. 3 times -2 is -6. 5 times 0, 0. 1 times -4, -4. -2 times -4 is 8. 5 times 1, 5. 1 times 1, 1. -2 times -1, +2. 5 times 2, 10. 1 times 3, 3. -2 times -2, +4. 2 times 0, 0. 2 times -4, -8. 3 times -4, -12. 2 times 1, 2. 2 times 1, 2. 3 times -1, -3. 2 times 2, 4. 2 times 3, 6. 3 times -2, -6. So let's simplify all that down. 4 minus 12, -8. 2 minus 4, -2. -3 minus 2, -5. 8 minus 4 is 4. 6 plus 2, 8. 14 and 3, that's 17. -8 minus 12, -20. 4 minus 3, 1. 4 plus 0, 4. B times A. So 0, 5, 4, 0, 1, 4, 0, -2, 6, negative 8, 5, 6, 4, 1, negative 6, negative 12, negative 2, and 9, negative 8, negative 5, negative 4, 4, negative 1, negative 4, negative 12, plus 2, negative 6, it's a 9, that's a 5, that's a 4, that's a 3, that's a should be a plus 6. Second row, second column, 3 times 2 plus 6, it's 11. That is negative 5. That is negative 17 is negative 1, and that is negative 16. Let's look now at number 19. A is equal to 2, 1, negative 3, 4, 1, 6. B is equal to 0, negative 1, 0, 4, 0, 2, 8, negative 1, 7. It's not a mistake that this one is 3 rows by 2 columns, and this one is 3 rows by 3 columns. So when I try and do A times B, this does not match. So this is not possible. However, when I do B times A, that's going to be a 3 by 3 times a 3 by 2, and these match, so I'll end up with a 3 by 2. So that's fine. Just need to give myself enough room for that there. So I have 0 plus 3 plus 0. Then I have 0 minus 4 plus 0. Then I have 8 plus 0 plus 2. I have 4 plus 0 plus 12. I have 16 plus 3 plus 7. Then I have 8 minus 4 plus 42. So that is 3, negative 4, 10, 16. 10 and 16 is 26. And then we have 50 minus 4 is 46. Let's jump ahead now to number 29. Assume matrix A is 3 by 4. Matrix B is also 3 by 4. Matrix C is 4 by 2. Matrix D is also 4 by 2. And matrix E is 4 by 3. Can we add A plus B? And if so, what dimensions will it have? Yes, their dimensions, their size is identical. So it will also make a 3 by 4 matrix. You cannot add or subtract matrices of different sizes. What about 33, which says A times C? So we're looking at a 3 by 4 times a 4 by 2. That's going to give us a 3 by 2 for our product. Now let's go ahead to number 55. We have the equation 1, 2, 3, 4 times A, B, C, D is equal to 6, 3, 19, 2. So that is A plus 2C. That is B plus 2D. And that is 3A plus 4C. And that is 3B plus 4D. Needs to be equal to 6, 3, 19, 2. So if I take the two equations that come from first column that only have A and C in them, then I should be able to say A plus 2C is equal to 6, and 3A plus 4C is equal to 19. And I should be able to solve those. I'm going to multiply the top equation by -3. -3A minus 6C equals -18. 3A plus 4C equals 19. So -2C equals 1 and C equals -1/2. If C is -1/2, then A plus 2 times -1/2 is equal to 6. A minus 1 equals 6 and A equals to 7. Now taking the other two equations here that are B plus 2D is equal to 3 and 3B plus 4D is equal to 2. I'm going to multiply this equation here by -3. That gives me -3B minus 6D equals -9. 3B plus 4D is equal to 2. And so -2D is equal to -7. D is 7/2. B plus 2 times 7/2 is equal to 3. B plus 7 is equal to 3. B is equal to a -4. So my answer is A is equal to 7, B is equal to -4, C is equal to -1/2, and D is equal to 7/2. Let's go ahead and look at number 59, which will be our last problem for this section. It's going to be A equals 2, 0, 0, -3, and B is equal to -5, 0, 0, 4. And they want us to look at the products AB and BA of these diagonal matrices, or we just have numbers along the main diagonal here and we have zeros everywhere else. I think they want you to draw some inferences here that this is the only time where order of multiplication won't matter here. So we have first row, first column here. We have -10 plus 0. Then we have 0 plus 0. Then we have 0 plus 0, and 0 minus 12 will give us -10, 0, 0, -12. When we have first row, first column here, we have -10 plus 0. Then we have first row, second column, 0 plus 0. Second row, first column, 0 plus 0. Second row, second column, 0 minus 12. It's also going to be a -10, 0, 0, -12. So for the most part, order of multiplication matters with matrices. This is the one exception here. Where order did not matter was when we had diagonalized matrices like this. But for the most part, A times B is not equal to B times A. That you would have to have square matrices like this that are diagonalized in this specific instance like this, meaning that there's zeros all along everywhere other than the main diagonal here. But that's it for this video here, and we'll come back next time and we will talk about section 2.2 and the suggested exercises from there. So I'll see you for the next video.